Okay, so we're going to be looking at dilutions today. And really quick, just a definition about what is a dilution. Whenever you dilute something, it just means that you are adding water to a particular solution to decrease its concentration. So there's two ways that you can perform a dilution. And then later on in the clip, I'm going to show you how to do the calculations for those as well, and the formula that we use for that. But the analogy that I always like to use to describe these two different ways that dilutions can be performed is just a little bit of a personal experience. So I used to grow up on a farm, and on the farm, my grandpa Orr was really good at making orange juice. He loved to have orange juice at family gatherings, and he was the guy that was always in charge of it. But my grandpa, because he grew up in the 30s during the Great Depression, was a pretty conservative person. And so what he would normally do is he would make the orange juice according to how everybody would make it, and then to kind of stretch it out to go a little bit further so that more people could have orange juice, he would take the jug that he had made the orange juice in, and then he would just add extra water. And so the orange juice was really just not very flavorful. It didn't have a very high concentration, and so because of that, the orange juice was really watery, as we would call it. And so that's one way that you can dilute a solution, is if you just take the entire solution and you just dump a bunch of water into that solution. Now this solution right here, before it was diluted, is what's called stock solution. And all stock means is if you've been to a grocery store before, let's say they're out of something like maybe bread and on the shelf, and there's no more bread on the shelf, you go up to sometimes a worker and you say, hey, do you have any stock in the back of this type of bread? And then sometimes they go back there and they'll look and see what sort of stock they've got. So a stock solution is just, this is what we have at a particular concentration, and this is sort of the base solution that we're working with. The second way to perform a dilution is what we all wanted Grandpa to do. Instead of diluting the whole thing, Grandpa, if you want watery orange juice, you can have watery orange juice, but if we don't want watery orange juice, then we would like to not have it. And so what we wanted him to do was, we wanted him to, if you want a glass of watery orange juice, take, say, 500 mils out of the stock solution, put it into a glass, and then add your own water to that. And then as people want to change the concentration of their orange juice, they can. And so these are the two different ways that you can perform dilutions. And you'll see problems that will do both, where we're adding water to the stock solution, or we're taking a smaller volume out of the stock solution, putting it into an empty container, beaker, whatever, and then we add water to that to bring it up to a particular volume. So let's say we're bringing this up to 1 liter. And so if I'm adding 500 mils of the stock solution, I would also be adding 500 milliliters of water to that. And so in the next clip, we're going to take a look at how to do some of these calculations and the formula that we use for it. And so we'll be right back. Okay, so here's our example that we're going to run through. The first thing I want to point out is the formula up here at the top. And the formula is such that it looks actually really similar to Boyle's law, in that we've got just sort of a initial and a final side to the equation, but instead of pressure and volumes, here we're dealing with concentration and volumes. And so the ones are the initial concentration and volumes, and the twos are the final concentration and volumes. And you can see that if you think about a dilution, for example, if the volume of the solution increases, then that's going to mean that the concentration is going to decrease. And so those two are inversely proportional to each other, thus why we see the formula look very similar to Boyle's law. Now, this problem here is question number 1 in your practice booklet. So we're just going to run through this together. Essentially what this example is an example of the first way that I showed previously in the clip of how to perform a dilution. And so if you read through this, it says that we've got a stock solution, and we talked about what that term means, of sodium sulfate. and its concentration is 1 mole per liter. So the stock solution is my initial solution, and so that's going to be my initial concentration, 1.00 moles per liter. And it says that the volume of that solution is 50 milliliters. And so I'm just going to write 50 milliliters there. Now, the question says, what volume of a 0.25 mole per liter solution? Well, I know this is the only other volume in the formula, so this is obviously what I have to solve for, which is V2, which means that concentration right there is going to be my final concentration. And if you look at the numbers and you look at the how things are changing here and what's described, it says what volume of a 0.25 mole per liter solution could be made from the stock solution. So it doesn't say anything about us pulling a little bit out of the stock solution and putting it into a separate container. This is just where we're going to be adding water to the entire stock solution and diluting the whole thing. And so this lends us to believe that this is the first way, or the first way that I described as to how to perform a dilution. And so here's our formula. I solve for V2. This is the formula that we end up getting, solving this algebraically, and I plug my numbers in to be able to solve for this. So I've got 1 mole per liter here, 50 milliliters there, and 0.25 moles per liter there. I plug that into my calculator. Make sure that when you write this into your formula that you are including all the units. And so we put the units in so that we can show that the units are canceling out. So we've got moles per liter cancel out on both sides. Right here I've got 50 milliliters, and again, just like a lot of the formulas in the gas unit for this formula, you just need to make sure that the units are consistent. So the concentrations will always be in moles per liter in that format. The volumes could be in liters or milliliters, whatever unit of volume you've got there, as long as the volume is consistent. So if this is in milliliters, then my answer is going to punch out in milliliters. So this works out to be about 200 milliliters, but when I round this to the appropriate number of significant digits, my answer is actually going to be 0.20 liters, and that's my final answer. So that's how you do this one. We'll do one more example illustrating how to do a dilution calculation using the second method, and then we'll wrap it up. So we're back with our final problem that we're going to use to describe the second method of diluting a solution. And so one thing I wanted to point out with the formula up here is I had this initial and final labeled on there, but if you think about the initial side of the formula being the information that you're being given about the stock solution, then that kind of helps you organize the information a little bit better. Also, anything that's related to the diluted solution is going to go over on the final side of the formula with C2 and V2. So if you take a look at this problem, this is question number 6 in your practice booklet, and it says what volume of concentrated nitric acid, which has a concentration of 15.8 moles per liter, should be added to water to form 500 milliliters of a 3.0 mole per liter nitric acid solution. And sometimes what ends up happening with these types of problems is it's hard for kids to kind of wrap their heads around what does this all mean. And so I think the best way to sort of understand sometimes these problems is to just draw a real simple picture. And so I've got a picture over here on the right hand side, and you can see what I've got here. I've got the stock solution, which is my nitric acid solution, has a concentration of 15.8 moles per liter. The problem doesn't tell me what the volume of the stock solution is. And sometimes also I find that kids kind of get wrapped up in that. It says, well, it doesn't give me that volume. In this case, we don't need it. All we need is we need to calculate how much of the stock solution we're pulling out to put into a separate beaker that we can then add water to bring the volume up to 500 milliliters. With a concentration of 3.0 moles per liter. So you can see this concentration is severely diluted from this one, which means we're adding a bunch of water. We want to know what small volume of this are we going to drop into here so that we can get these two numbers. And so if I'm organizing this again, my C2 and V2 are these numbers over here for the diluted solution. And so this is going to be 500 milliliters, and this is going to be 3.0 moles per liter. The problem is asking for a volume. What volume of water, or sorry, what volume of concentrated nitric acid should be added? So this is what we're looking for V1. And so my initial concentration is just going to be my stock solution concentration, which is 15.8 moles per liter. And so then I can just solve for V1. V1 is equal to C2 V2 divided by C1. I plug all those numbers in. I get 3.0 moles per liter. My volume's 500 milliliters divided by my initial concentration, which is 15.8 moles per liter. And I plug all that into my calculator, and I end up with 95 milliliters. My answer is written to 2 significant digits because this number right here, 3.0 moles per liter, is the number that has the least number of significant digits in it, which is just 2. So my answer is written to 2 sig digs. And so that's it, guys. That's how you do dilution calculations.